This screencast goes over how to solve a system of equations by graphing. The first one we're going to do involves using the equations y equals negative a half x and y equals x minus 3. In order to be successful in graphing, we need to make sure they're in slope-intercept form. At least that's the quickest way to do it. In this case, they are because they're both already solved for y. So the first equation has negative 1/2 x. Technically here, even though it's not written, there's a plus 0, and that tells us our y-intercept. I'm going to graph this one in red. Since the y-intercept is 0, we're going to make a point at our origin. The slope is negative a half. We're going to count down 1, which takes care of the negative, and right 2, positive. I can keep going that way, or I can go up 1 and left 2. Now, to make my graphing process a little bit easier, I'm going to draw in some guide dots. And there is y equals negative a half x. I'm going to do y equals x minus 3 in blue. So we're going to go down 3, that is our y-intercept, and make our point. Our slope is 1 over 1, so we're going to go up 1, right 1, or down 1, left 1. And again, I'm going to put in a couple of guide points to help make my life a little easier. And there are my two lines. I am looking to see if they intersect, because where they intersect is what points they have in common. There is an intersection right here, and it is at the point 2, negative 1. That would be the solution of the system, and what that means is it is the only point that works for both. Since there is one solution, the system is consistent, and it is also independent. So if I'm asked to classify the system, those are the two things I would need. Consistent means there is at least one solution. Independent means that we have exactly one solution. Next example we're going to do is x minus 3y is equal to negative 3, and 2x plus y is equal to 8. In this case, neither equation is solved for y. So I'm going to take the first equation and subtract x from each side. That gives me negative 3y equals negative x minus 3. Divide each side by negative 3. And that gives me y is equal to positive 1/3 x plus 1. Second equation, I need to subtract 2x from each side to solve for y. And y is equal to negative 2x plus 8. Graphing in red, the y equals 1/3 x plus 1. Go up 1 for my y-intercept. Slope is 1/3, up 1, right 3, or down 1, left 3. For y equals negative 2x plus 8, the y-intercept is at 8. Slope is negative 2, down 2, right 1, and that's really all I have room to do. Again, you will notice, like the previous example, these two lines intersect in one place. That is the solution they have in common, which is 3, 2. They do intersect, which means the system is consistent, because they have at least one solution in common. And since there is one solution, it is independent. Third example we're going to do is 6x plus 3y is equal to 12, and y equals negative 2x plus 2. One equation already solved for y, the top equation is not, so I'm going to begin by solving for y. Subtract 6x, and I get 3y equals negative 6x plus 12. Divide everything by 3, and I get y equals negative 2x plus 4. Might notice that both equations have negative 2x, and that would tell me they have the same slope, but they do have different y-intercepts, so I will go ahead and graph them. 4 is my y-intercept on the first one, down 2, right 1, up 2, left 1. So first equation's in red. Second equation we'll do in black. Y-intercept's at 2, up 2 on my y-axis, and down 2, right 1, or up 2, left 1. Because the two lines have the same slope, they do not intersect, so they have no solution. When two lines do not intersect and have no solution, it is an inconsistent system. The last example we'll do is 4x plus 2y is equal to 10, and 10x plus 5y is equal to 25. First equation, I'm going to subtract 4x from each side so that we can, again, get it solved for y. 2y equals negative 4x plus 10. Divide everything by 2. And that gives me y equals negative 2x plus 5. Second equation, subtract 10x from each side. That gives me 5y is equal to negative 10x plus 25. Divide everything by 5. And y is equal to negative 2x plus 5. Well, gee, that's the same equation I just got a moment ago. So in this case, I'm going to end up with exactly the same line. Again, y-intercept at 5, go down 2, right 1, or up 2, left 1. Whoops, I don't think I quite did that right. Okay, let's try that again. Up 5, down 2, right 1, or up 2, left 1. There we go, that looks a little better. In this case, we have one line, so that means they have every solution in common. That's called infinitely many solutions. And again, there are solutions in common. The lines do intersect. Technically, they intersect everywhere, so it's still consistent. But because they intersect everywhere, it is consistent and dependent. So that gives you how to graph a system of linear equations. Have a great day.